All right, let's continue solving for our variables in these rational equations. So if you were finishing from the last video, we did the first two examples that you see on the slide, and now we are on the third. So our strategy is to look at the domain first, and then to use the common denominator to clear out the denominators in the equation. So taking a look at number 3 and talking about the domain, remember we're looking for the values that are no good for the variable. The value that would make this denominator 0 would be -2, and the value that would make this denominator 0 would be 0. So my domain would be all reals except for -2 and 0. Those would be the values that are no good. All right, so let's use the least common multiple or least common denominator to clear out the fractions. Our least common denominator has to have the product of all of the different factors of all the denominators. So in this case, our LCD would be p plus 2 times p. So I'm multiplying every single term on both sides of the equation times p plus 2. When I do that, things will cancel. So multiplying the first term here, this is just a 2, so nothing's going to cancel. The denominator is 1 anyway. So I have 2 times p, which is 2p, times p plus 2, minus. For this term, the p plus 2's will cancel, and I'll be left with a p times 3, or 3p. On the other side, the denominator of p will cancel with the p here, and I'll have 6 times p plus 2. Right, so now we can clean this up, see what kind of equation we have. If it's a polynomial equation or a linear equation with 1 degree, 2p times p is 2p squared. 2p times 2 is 4p, and then minus 3p. Equals, distributing the 6p plus 12. So once I see a term with a degree of 2 or higher, then my strategy is to get all of the terms on the same side and try and factor. So I'm going to subtract 6p and subtract 12. Do that in one step just to save a little bit of writing. I don't have a like term, another constant here. I actually have these 3 like terms that I have to combine. So I'll do that. 2p squared. So I have these 3 terms. 4p, -3p, -6p. So the negatives give me -9, plus 4 is -5p, and then minus 12. Again, if you need to pause this video just to kind of stop and make sure that I'm doing all my steps correctly and that you kind of understand, that's fine. But I want us to focus on the newer stuff rather than the older stuff here. All right, so I need to factor this polynomial in order to solve for p. This is a trinomial, but the leading coefficient is not 1. So I could use grouping here. Multiplying the 2 times the -12 gives me -24. So I'm looking for 2 numbers that multiply to -4, but add to -5. I need to have opposite signs to get that -24, and those 2 numbers would be -8 and +3. So I'm going to use that to write my polynomial in 4 terms. 2p squared minus 8p plus 3p minus 12 equals 0. Now I can factor the first 2 terms and the second 2 terms. I'm just going to move this up here for some space. My GCF for the first 2 terms would be 2p. And when I factor out a 2p, I'm left with p minus 4. For the second group, my GCF is 3. And I'm left with p minus 4 again. Remember, when you're factoring by grouping, you want those leftover polynomials, is what I call them, but you want them to be exactly the same. So now my factorization is p minus 4 times 2p plus 3, and that equals 0. All right, so once we have factored, then we can set each factor equal to 0 and solve. So p minus 4 equals 0. 2p plus 3 equals 0. P minus 4 equals 0 tells me that p is equal to 4. And if 2p plus 3 equals 0, then that means that 2p is equal to negative 3, and p is equal to a negative 3 halves, which I'll write over here. So we have two solutions, 4 and negative 3 halves. We should check those solutions with our domain. They agree with our domain. We said we can't get negative 2 or 0, and we didn't. So then it's up to you to go back and check to make sure that these values make sense for the original equation. So you can plug it in and simplify each side and just make sure that they both work. So in this case, our solution set would be 4 and negative 3 halves. Okay, let's take a look at the fourth example. So here we have a nice equation because now we have some trinomials to deal with and some more factoring with trinomials as well. This written out, kind of crowded from the example before, so let me move that up, get that out of your way visually. All right, so again, we're looking for the domain, looking for values that are no good so we can make sure to stay away from them. And we need to use our least common denominator to clear out the fractions. So what I need to do first is factor all the denominators that I have. This is a linear factor, there's no GCF, so it's its own factor. Another linear factor, no GCF. For this trinomial, let me just write the factorization right underneath. So it's a trinomial, the leading coefficient is 1. So I'm looking for two numbers that multiply to negative 18 and add to negative 3. Those numbers will be negative 6 and positive 3. Doesn't matter which order I put them in. So I'm just replacing that denominator with its factored form. This also helps me find my domain because if I have my factors, I could easily see what values are going to make the denominator 0. So negative 3 would make this denominator 0. So my domain would be all reals except negative 3. A 6 would make this 0. So I want to exclude 6. And then those same two numbers are going to make these 0 as well, because the 6 would make that factor 0 and negative 3 would make that one 0. So those are all the values that I want to make sure I stay away from. And now I could use my LCD. My LCD is the product of all of the different factors. So my different factors are x minus 6 and x plus 3. So I'm multiplying every single term by x minus 6, x plus 3. If you want, instead of putting parentheses around each side, you could right next to each term write in that product times x minus 6 times x plus 3. Same thing here, multiply by x minus 6 and then x plus 3. And then here as well, multiply that numerator by x minus 6 times x plus 3. And there's a lot of writing, so try to do it neatly, and if you can, avoid having to write more out, then that's fine. Okay, so now I'm going to cancel out my denominator. The x plus 3 cancel, so I'm left with 4 times x minus 6 plus, here the x minus 6 cancels, 5 times x plus 3. On this side, the x minus 6 and the x plus 3 both cancel, so I'm left with that 4x plus 1. All right, so that equation looks a little bit cleaner, but I need to, again, look and see what kind of equation I have. So I'll distribute that 4, and then distribute the 5. See if I have any terms that are degree higher than 1, which it doesn't seem like I do. So I'll go ahead and combine like terms on the left side here. That's 9x. Negative 24 plus 15 gives me negative 9, and that equals 4x plus 1. Since this is linear, I want to get the variable on one side and the constant on the other. So I will subtract 4x. That gives me 5x minus 9 equals 1. add the 9, and I have 5x equals 10. If 5x is equal to 10, then x is equal to 2. So I have one solution here. I should check that solution with my domain. My solution is 2. Remember, my domain I said was all reals except for -3 and 6. So I'm allowed to get any value except for -3 and 6. And 2 is not either of those. So that is my solution, 2. Okay, we'll take care of the other examples in the next video.